Now I will request all the delegates to kindly take their seats below the stage as we will now begin the plenary talk. Ladies and gentlemen, it's time for plenary talk on self-reliant AI/ML in engineering, education, research, and technology development. We are honored to have Dr. Sanak Mishra, former President INAE, to steer the session. Dr. Sanak Mishra is a professor of practice at COEP Technological University, Pune, and past president of INAE and the Indian Institute of Metals. He has also served as chairman of the International Organization of Materials, Metals, and Mineral Societies, and as a governing board member of the Steel Research and Technology Mission of India. His distinguished career includes leadership roles at SAIL, ArcelorMittal, as Vice President and CEO of India Projects. As the first Secretary General of Indian Steel Association, he contributed significantly to the National Steel Policy 2017. Recipient of the Lifetime Achievement Award 2018 from the Ministry of Steel, Dr. Mishra has won the National Metallurgist Award, G.D. Birla Gold Medal, and J.R.D. Tata Award for Corporate Leadership. May I now request Dr. Sanak Mishra to kindly come on the stage and invite our esteemed speaker, Professor Partha Pritam Chakrabarti.
It gives me immense pleasure, and I think it's a privilege for me to invite the plenary speaker, Professor Partha Pratim Chakrabarti, fellow of the Indian National Academy of Engineering. A very eminent, a brilliant scientist and an eminent educationist. Professor Chakrabarti completed BTech degree in 1985 and a PhD degree in 1988 from the Department of Computer Science and Engineering at the IIT Kharagpur. He was director of IIT Kharagpur from July 2013 to July 2019, and then he was professor in charge of the state-of-art VLSI Design Laboratory and was Dean of Sponsored Research and Industrial Consultancy at IIT Kharagpur. He had set up the incubation program at IIT Kharagpur and was head of the Advanced Technology Development Center. His areas of interest include artificial intelligence, algorithms, formal methods, CAD for VLSI, and embedded systems and fault tolerance. Professor Chakrabarti has made fundamental scientific contributions in the area of artificial intelligence and automated reasoning, and has applied these techniques to solve important synthesis, optimization, and verification problems, especially in VLSI design and embedded systems. He has published 2 research monographs, more than 300 papers in international journals, and has supervised more than 30 PhD students. He has successfully completed projects with MHRD, DST, CSIR, etc., and also has worked with private corporations like Volkswagen Foundation, Intel, Synopsys, Google, National Semiconductors, General Motors, ONGC, etc. He was the founding architect and overall coordinator of national initiatives like the National Digital Library of India, the Global Initiative for Academic Networks, Spark, Imprint, and Pan IIT ONGC Institute. Dr. Chakrabarti has received several awards, such as the President of India Gold Medal 1985, that's for securing the highest marks in the batch of 1985 at IIT Kharagpur, the INSA Young Scientist Award 1991, Anil Bose Award 1995, INAE Young Engineer Award 1997, Swarna Jayanti Fellowship, Santi Swarup Bhatnagar Prize, the INAE Viseswaraya Chair Professorship, the J.C. Bose Fellowship, etc. He's a fellow of the INSA, he's a fellow of the Indian Academy of Sciences, Bangalore, and of course of the Indian National Academy of Engineering. He has received an honorary DSc degree from Kalyani University in 2018 and an honorary DLit from Techno India University in 2024. So here we have a very eminent personality who will talk about the self-reliant AI and ML in engineering. He's going to cover a very large canvas like a painter, and it'll cover education, research, and technology development. And so I take great pleasure in inviting Professor Chakrabarti. I'll take a minute having Professor Chakrabarti here by my side. Please, Dr. Chakrabarti. I think as a chairman, I just want to speak of this session. I want to speak just a couple of minutes. The fact is that I noted in the abstract written by Professor Chakrabarti that he has used the term modern AI. I was very, what shall I say, I was very happy to say that, because artificial intelligence, as all of you know, is not a new concept. It's been there for several decades. And the concept of machine learning is a newer concept which talked about training of models. I think the early generation of smartphones, we already had artificial intelligence. But I think that's artificial intelligence of a different generation. What you have seen in the last 10 to 12 years is the modern AI that Professor Chakrabarti is referring to. The modern AI, of course, saw the development of the large language models, the LLMs, the ChatGPT and so on, which basically summarizes or which basically collates and produces a report. The information of that is already available. I think with the new generation of AI, I hope you will be talking about that, is the regenerative AI, which can generate original content, which can generate a piece of art, a painting, which can generate music, very modern music that we haven't come across at all. So I think we are going to hear something very fascinating from Professor Chakrabarti. I leave the floor open to you, Professor Chakrabarti.
Thank you so much, Dr. Mishra. I'm grateful to INAE and obviously to IIT Kanpur, Professor Manindra Agarwal, Dr. Patil, Professor Shantanu Chaudhary for inviting me. I come once in maybe 2-3 years down the line in IIT Kanpur, and it's very refreshing, and I always have a lot of fun. But today, the topic, as Dr. Mishra has mentioned and the previous chairs have mentioned, this side is three human beings were so trained that they could look at this cockpit of the Concorde, which flies at Mach 2 speed plus, which is now is not used anymore. But only 3 human beings were trained to operate such complex machines, which means that the human beings were really, really well trained. And then today's modern AI, we have trained AI so that 12 robots have gone together, and because they have been trained with large language models with human mentalities, they have gone on strike. So they've gone on strike discussing work conditions. So this is the gamut that we have come to, and we shall have to address as we go ahead. We develop science and technology over a period of time, and at this end of the day, we came through these 2 cycles of computing and electronics, and then that transformed to artificial intelligence and cyber physical systems, which is obviously the topic of today. And throughout this history of scientific development and knowledge, it has gone through 5 phases. The first is about observation. Unless you observe new things, you really cannot. And then from these new observations, you discover new knowledge, from fire to wheel to whatever. And then you build theory to applications and deployment at scale, of which the mobile phone that we use is a big example. Computing changed all science. it became the spouse of every discipline. Computational physics, computational chemistry, computational sociology, digital humanities. So it became every discipline's spouse. But the difference was that everybody knew the difference between the discipline and the computational part of the discipline. AI has gobbled the discipline. AI now speaks based on computation, but speaks in the language of the discipline. It speaks to the physicist like a physicist, not like a computational person. It does not show programs, it shows you equations. So from when we came from computational to intelligence, we started solving problems which were solved individually by different programs or by different computational agents. The goal was to solve it by one mega method. But when we tried to solve it with one mega method, we started getting a lot of successes. We want to solve the Google map finding problem, to the chess problem, to the VLSI chip design problem, to the timetable scheduling problem, to the integration to the robot assembly problem, all of which have configuration spaces or state spaces or exploratory spaces whose sizes are close to the number of atoms of the universe. And we started getting successes in that. But then we realized, as Dr. Mishra and everybody said, that this sort of mechanism is now able to assimilate all the data which looks heterogeneous, find patterns amongst them, and provide you with descriptive, predictive, preventive, and prescriptive methods for everything. It is able to look at complex phenomena for which we do not know even a single equation or even a set of equations, but is yet able to predict certain things about those for which human beings cannot conceive of equations. Therefore, it is able to discover things which a naked eye or a human brain finds it difficult to do with its own short-term memory. But the world that we live in is much more complex than even what AI can do today. Because the real world has undecidable problems. The real world has intractable problems. It has multi-objective, multi-dimensional, multi-party problems. And Indians are experts in handling all these issues, because Indians think that, the most difficult multi-party problem, multi-dimensional problem is handled by people like the Prime Minister, and all Indians know how the Prime Minister should behave. Now, there are 3 or 4 steps. Therefore, the information that is available is also partial. This is the gamut, if you want to put this in one sentence. Therefore, the solution comes in many forms. AI is not a single solution animal. AI is a personality which inside it has multiple things. And I will try to distill out in a crude fashion, and you have to pardon me for being so crude though I am supposed to be an engineer and a scientist. There are 3, so I call this the star of AI. Like you have the Star of David, in all our philosophies, you'll have this diagram with something inside. So all of AI has got the first top triangle. The top triangle consists of 3 parts. The first part is the model, representation. Because I want to have a generic method to solve all problems. So I must have a generic method for representation. From that representation, I must have a reasoning engine or a solver. Any problem, I should be able to represent generally, and any problem from that representation I should be able to solve. And the third leg is learning, that as I solve, I learn to solve it better and better and better the next time I solve it. So this is the first triangle of AI. Then AI has got the second inverted triangle. The second inverted triangle comes from methodologies. And AI is a master in absorbing other people's methodologies, renaming it and calling it AI. The first is all of algorithmic AI, where representation is data structures, reasoning is algorithmic, and learning is algorithmic. This is the first step, where all three are algorithmic. AI calls it symbolic AI. The second is statistical, where representation is statistical, solving is statistical, and learning is statistical. AI has given a new name, called it data science. The third, when they found that neither algorithmic is able to solve a certain set of problems, nor statistical, because statistical eventually leads to functions, distributions, which we want to write down. So they went and created these artificial models based on these nonlinear nodes called neurons. So they created this connectionist or neural model, where again the representation is neural, the reasoning is neural, and the learning is neural. And then all three got combined today. And today, representation is a combination of symbolic, statistical, and neural. Solving is a combination of these three, and learning is a combination of these three. And these bootstrap each other. The better the representation, the more improved the reasoning and learning. The better the learning, the better the reasoning and representation. The better the reasoning, learning improves, and then representation improves. So that is how this is a regenerative cycle. But since we are solving problems which are intractable with limited information and everything else, therefore, the solutions are not crisp. The solution, if you want to understand it in linguistic terms, all solutions of AI are probably approximately accurate. What does it mean? It means that I will tell you that I will be 90% accurate with 80% probability. I will be 80% accurate at least with 95% probability. So all of AI is probably approximately accurate. A crude way to understand why this happens is, for us, it's a very crude way, just take it as a crude example, is that we all do interpolation. Given X and Y, some data, some unknown X, I want to know Y, and for unknown Y, I want to know X. This is our standard problem, which translates into classification, regression. And we typically have this X as a numbers, so there is an ordering, and Y is another set of numbers, which there is ordering. Now, let us assume that this X is 1 billion dimension, and Y is 1 billion dimensions, and each of these dimensions are pictures, words, sentences, emotions, which means that some of them have linear ordering, some of them have partial ordering, and some of them have no ordering at all. And it is an interpolation in this dimension. It is an interpolation in this dimension. Given X, I find Y, which is called predictive AI. Given Y, try to find X, which is called generative AI. Very crude way. And every such interpolation will have error. And all this error is manifested in AI. It gets different names. Sometimes it is called error, sometimes it is called hallucination, sometimes it is called whatever. All of it is because we have not been able to manage the error. So it has got various names. At the base of all AI is, at the base of all things human beings do for research is search. They search for a solution. And whether it is in learning, whether it is in reasoning, or whether it is in combinatorial solving, at the heart of it is search. And the fundamental theorem of AI is knowledge versus search. The better your knowledge, the less your search. So you had logic, you had language, and language is the holy grail because that is our mode of communication. Human beings cannot understand that 5 billion dimension space. You need to express it in some language, symbolic, and things like that. And language, as we all know, is so interesting in terms of its ambiguity, in terms of everything that we have. In terms of data science, you have, all of you know that there is supervised learning, where you've given trained data and you then use it for predicting next part, which is the training. Then you have unsupervised learning, which you learn from patterns. And then you have this reinforcement learning, which we all learned when we were children, when we put our hands in the plug and we never put it back again next time. Then this huge concept of taking circuits. Circuits, as we know, were gates. And with gates, we know that we can design so many kinds of functions. The most brilliant thing to have done is replace one gate by a nonlinear function like this. There are many kinds of such functions. And then came those universal theorems, which said that if I have got a combinatorial circuit with these nonlinear gates, then I can realize any function to any accuracy, only the number of gates will change. This is the fundamental theorem. The second, they said, this is for which Hupfield got his Nobel Prize. He said that if you connect everything to everything, then it behaves in many ways, including an associative memory. An associative memory, like to us, is like, you draw half a diagram with two spectacles and you're drawing Gandhiji, half of it. So associative memory comes from all-to-all connected networks. And if you have a combination of combinational circuits like this, and some of them come back with feedback, here everybody has feedback, part of it, all of us in computing know that, or digital circuits know that this is a sequential circuit. But this sequential circuit, when it has these nonlinear components like this and behaves asynchronously, starts behaving like memory, short-term memory. So these neural networks, along with some more fundamental kinds of competitive networks and others, yield a variety of paradigms for us to do computation. Earlier, human beings would extract features and give it to machine learners. Later on, it was found that you can make it deep enough, and that is why the term deep learning. Nobody even needs, you just need to provide data. And then people started doing it for images. People started doing it for sound signals, that means sequential data, and came up with various architectures for machine learning. And then we have knowledge representation, and as Dr. Somnath was mentioning, we have the cyber physical systems, which consists of sensors, actuators, data acquisition, features, models, planning, and everything else together, which forms the architecture of the cyber physical system, where all of this machine learning and data science is impregnated. And what has that done? That has enabled us to do things which human beings thought was impossible to do. First, this is Kasparov losing. This is a digital twin This is the Mars rover. This is the robo-citizen. This is the surgery that you were talking about. But other than just the scientific development of computation, AI, and electronics, as well as newer equations that people have found from studying and understanding things, three things that have made it possible for us to achieve this. First is compute has become free. In your own pocket, you have compute, as was mentioned, which even 10 years ago was not available in machines of this big size. Storage has become free. It has become the biggest garbage dump. Our biggest garbage dump is our hard disks, right? We even don't know what is there where. And communication has also become free. Our only bottleneck today is power. Once we get access to new power, and once we go back to our classical model, where in AI, I left out one small, tiny part here. Once this dimension gets added to this triangle, we are going to see a breakdown of almost everything that we consider. And I know that some of our cybersecurity and crypto people here are already talking about post-quantum stuff. So this is still not modern AI. This is still not modern AI. This is modern AI. So what is modern AI in one slide? Half of my slides, please be careful, in the corner, it is all credited to somebody else. I go and attend these conferences, take away their slides, add it to my slides, and come and present it all to you. So there are two kinds of AI. First is the predictive AI. As I said, in that multi-million, billion dimension model, given X, tell me Y. What is that? You'll be given a picture, you'll be told this is a man. You'll be told this is walking. You'll be told approximately middle-aged. That means, given some detailed description, you're distilling out some important aspects of that description. And you're trying to tell people that this is something about this person, about this picture, this sound, this story, this sentence, whatever, you distill it out. And the predictive AI models create this and create this. This orange is the representation that I talked to you about. This is the representation. So you learn everything into this orange colored representation and use it to predict. The reverse is generative AI. I tell you, show me a picture of a 60-year-old man walking with gray hair. So it is taking the model, taking a cue, which we all call a prompt or whatever, and generating the input to what was given here. That means I now have another network which does the reverse of what I did earlier. And when I combine these two together, then I have the structure of my modern AI. It will take a song or a sentence or a music written by you or a few sentences of an idea from you and will sing it in Lata Mangeshkar's tune, in Lata Mangeshkar's voice, but in the tune of some British singer. And then, when you have this, what are you going to train it on? Modern AI says, I will train it on everything. I will train it on all the knowledge that is available in the world. And when I train it on all the knowledge that is available in the world, magic happens. That means I am able to hear stories of something, music of one language in another. I am able to now correlate the internal structures, the internal representations of language, which we all studied in linguistics, is that there is the Indo-European languages. It will be able to find even better and deeper connections when it has more and more data and knowledge. So, based on this, you create what is the term that is used is the foundation model. And that is the big foundation model trained on anything and everything that we see behind ChatGPT and things like that. And then now you say that from this model, I want to only analyze, tea leaves which have gone, diseased. So you can fine-tune it. And this fine-tuning was used based on data, but today, fine-tuning that you do is based on language. It has become so sophisticated that you can fine-tune it based on language. You say, no. You create a model for me from your foundation model using the data that you have from tea gardens, plus this additional Excel sheet that I'm uploading for you. This is the sophistication to which it has taken it, and that is how it creates a model for diseased tea leaves. You have some additional data, you add it up to that site, and it will give it to you. So this is the architecture of ChatGPT, but it was still producing very, very nasty outputs. So because of this nasty outputs that it was producing, it started getting trained by human beings. So that training by human beings is called RLHF, Reinforcement Learning with Human Feedback. And this happens all over the world all the time. In Africa, people are paid very pittance and asked to do lots and lots of training so that you do not get results which are violent, which are things like that. And all the time we pay ChatGPT or Grok or whosoever to give us results, we are also training that fellow free of cost by paying that fellow. So sometimes, and if you have realized, you should also know that it never argues with you. If you start arguing with it, it will say, sorry, this, that. So if you're angry with it, make it do wrong things. So that, you've paid for it, let it find out what errors it makes. So what has modern AI done? And what are the capabilities of modern AI that makes it so transformative? People took equations without naming all the atoms and molecules. Just converted it and de-anonymized it and took all the equations possible and said that now that I have de-anonymized it, anonymized all the names, now from these equations, try to put them, cluster them in a tabular form in such a way that those which are closely related are together. And it's the table-driven representation of this clustered form. Can anybody tell me what it gave? It gave the periodic table. The periodic table is considered, along with Paninian grammar table structure, considered one of the most ingenious, compact forms of representation of knowledge that we ever had. But this is automatically discovered. It is predicting organic synthesis 5,000 times faster than a human being. Today's graph neural networks are predicting structure to function. If you see, there are all publicly available tools in material science, which, given the structure, will predict function. We ourselves did some work on predicting aerodynamic lift parameters with very, very good accuracy. Software, as Dr. Somnath was mentioning, the huge amount of software, correcting software, summarizing software, integrating software, All of us who have gone through debugging huge software libraries and code know that when 30 people or 300 people are doing software, how do you know? You have got into a project. How do you know what is it? What is this code? How does it look like? It has reduced their learning time, training time drastically. The first AI-generated textbook on lithium-ion batteries was considered the most authentic textbook ever. In 2019, people took data, they read books, they made AI read books of related to thermoelectric materials, books and papers up to 2009. So AI was asked to just read books and papers on thermoelectric materials up to 2009 and predict the next one. The 5 materials that it predicted were discovered by human beings in 2011 and 12, which means that the power of prediction is faster and higher than even the top scientists in the world. AI has still not been able to, given past knowledge of 1800s, AI has still not been able to predict relativity. AI has still not been able to predict quantum mechanics. So let's take it with a pinch of salt that everything is not so hunky-dory. Look at this guy. 18-year-old Matthew Paz, since NASA gave he surveyed 200 terabytes of astronomical data from NASA on his computer in NASA and discovered 1.5 million new space objects. 18-year-old guy. This is the power it gives intelligent people. It is the power it gives people who really want to pursue science. This is the power of AI and data science. We know that protein structure, one protein structure, one PhD, 5 years. One result, they predicted 200 million protein structure through AI, which means 1 billion PhD man years, one equivalent to 1 billion PhDs. And obviously, last year we know the Nobel Prize in Physics and Chemistry were all given to AI engineers, but they were not the first AI people. Economics also got the Nobel Prize in 1978 by Herbert Simon. Now we come to cyber physical systems and intelligent machines. Once that is integrated with intelligent machines, we are able to do anything now. Printer optimization, defect analysis in electron microscope. This is my student who runs a company on digital pathology in Bangalore. Nothing. What is it? He started with motors and webcam. Just motors running around, taking multiple images and just run AI algorithms. So it is 1/10 or 1/10 the cost or 1/5 the cost of a Siemens with the same accuracy. So for those in manufacturing which was being talked about, whether it is in real-time monitoring and control or robot control or health monitoring, and our president will know this to the best way possible, whether it's in welding. Today, it will not only weld, it will help the person move their arm better. In additive manufacturing, in autonomous robots, we all see that everywhere. We've heard of this, but today, John Deere will give you the tractor for free. What they want is your data. They will give you your tractor for free. All they want is your data. And Google and others don't even ask for your data. They know everything, no? Because you talk to your wife says, "Nahi, tomorrow we should buy a sari for that wedding gift. Ab jao office mein kholo, sari, 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 sari. So everything is known about you. Please don't take it otherwise. You want to test how everything is known about you? Simple test. They will ask you, you are doing something on a web browser, they will ask you to download the app. If you don't download the app, they won't give you all the features. You test it, I'm telling you. From Facebook to anything else, you try not doing it with the app. The app means gone. So extended reality is coming up, and I think that integrated with AI, with that immersive experience, is going to change engineering and learning and everything else. So now, the postmodern AI. AI has become a researcher. How has AI become a researcher? Today, the LLM is telling you that this is the next possible set of materials. From that, it is generating the equations which you can give it to a simulator. From there, it is reducing the possibilities coming back. After 2 and 3 back and forth, it will give you 4 possibilities for which you actually run the experiment. And this has become the complete trend for knowledge discovery and research. And Sam Altman has put up a challenge. He has said that it will be better than a PhD researcher in the next 2-3 years. So, previously when we were young, some of my colleagues here, when we used to do PhD, and our students, you remember all our titles of our PhD thesis? A method for, some studies on, etc., 5, and then the topic, and then something else. There used to be 3. Some studies on heuristic search in welding. So we used to guess PhD thesis topics this way. But now, in Jadavpur University, and in many other universities, I don't know if it is still there in Jadavpur universities, in many universities in big cities, there are people who come and solve your problems. You have a lab experiment to do, bahar karke fir you can come back and do it. Is it still there? Anyway, we won't discuss it. So now, it will do your PhD thesis for you. So there are now companies who advertise. Haven't you seen that they do your PhD thesis for you? They'll write your thesis only. Papers though is already done. So all of us have a good, just 1 or 2 subscriptions of these tools. But then you must know how to de-anonymize so that these tools also have mechanisms by which you can make out the tool has been used. We teachers, looking at a student's report, ये ChatGPT नहीं है तो ये तो Grok है, हाँ sir. So we have figured it out. So now coming to design, the speed, the turnaround time for any design, engineering design, whether it's a rocket, whether it's a chip, whether it's a power system, has dramatically reduced because of these foundation models guided by LLMs. So I'm just giving you a couple of examples to show, here is a work, high-powered rocket design using LLMs. All of you are aware that ANRF has come up with some of these calls for the ANRF latest call, Maha call, which is all about this. All about these terrifically difficult problems, whether we can use modern AI to solve it. This is a new one, very interesting. This is for power electronics design. You take a query, it retrieves knowledge from power electronics database, then it goes to an LLM agent, runs it through model, then uses physics-driven understanding to check whether all the physics is correct, then goes back to the simulator, and then creates the neural network to get the fine-tuning and produces the result. And then you just have to check it once or twice. You go today, even give it to straight to ChatGPT, you ask, you want to design a circuit and ask for Verilog code, it will give you the code. And then you just have to do a little bit of fine-tuning. Today, when we teach coding, I know in IIT Delhi, they have already come up with a mechanism by which they teach coding in two ways. First, you do coding without any help, and then you do coding with the help of LLMs. And they have trained it, isn't it? They have trained the LLMs in such a way that you can give lab experiments so that they can use LLMs to create code and correct it and modify it and make it better. Discovery. Derivation of physical equations of high-speed laser welding using large language models. So it's deriving equations of welding with parameters which human being does not know. But it's deriving these equations. And then you can go and check it. Obviously, you need to check something. But what I'm trying to bring to the fold is engineering and education are undergoing massive changes. We did this work ourselves, in which we started generating ideas, testing the ideas for quality. Then, as Dr. Somnath was mentioning, integration of the human being. Once you start the integration of the human being, there are three aspects. Whether the human being will assist you, it will tell you this is possible and you take the decision. Whether the system will take part of the decision itself, and you can only stop it. The third is there's nothing you can do. You will come wearing glasses, one chip on your head, and max JEE exam and go away. What is the problem? Everybody will max JEE exam. Because I know that some of my students have already designed that their problem solver, I will show you one example. Their problem solver on the past JEE exam, without knowing the exam paper before, with the exam paper, it gave the exam paper and its rank is AIR, above AIR 1. Its rank is above AIR 1. IIT JEE. All of us will fail if we give it again. Understanding human behavior, the toughest part. The toughest part of understanding human behavior, facial recognition, but it still is not able to do certain kinds of human recognition. Like when your girlfriend tells you, okay, I'm going, it means you have to say, don't go. That it still cannot do. That it still cannot do. So Alzheimer's disease was mentioned. We have a technology by which we are predicting progression of Alzheimer's disease to very, very high levels of accuracy. So all your eye tracking, your BMI and everything else, human robot prediction. When you're trying to do something, so robot is going to be able to predict what you want to do. These are all results. I'm showing results from papers. And finally, by just looking at fMRI signals, they are able to convert it to sentences. The other project is a computational brain that tries to work like a human brain. So what are opportunities for India? For India, I think the first opportunity, while we go on making Sarvam AI, etc., target convergence. Use AI to solve convergence problems. The ability of AI to take data from multiple diverse disciplines, integrate it together, is going to be the biggest gain, the fastest gain, and the lowest hanging fruit for ourselves. So whether it is in infrastructure, transportation, healthcare. I don't want to go into details, but I have all the ideas of what to do here. And then social convergence, food sustainability. How will I integrate end to end? How will I integrate end to end from production to what is available at your end? And that is where sustainability comes very important and interesting. So the whole of sustainable food and agriculture, I think, is something India should target dramatically and get there. Urban observatories. The whole of a city should have an urban observatory. It is easy to do that. All the major cities of the world have urban observatories. Climate change modeling. We have so many things going on, but do we have an integrated climate change model for ourselves? I presented this with ONGC. We are paying Halliburton to do our analysis. We are giving them our data. They are using our data to charge us to do the next analysis. Rural development. I think India should target these things for AI. Very clear targets, engineering and things like that. And then your mountains, your rivers, your ghats, your materials, your design, your tea, your coffee, all of this that we have is amenable to huge value addition when we use AI/ML. We are trying to understand and got stuck trying to understand Indian raga system using AI, and it's floundering, which means there is something more to it. Education, everything, the biggest problem with education today is that the students know how to use AI better than you, better than teachers like me. And therefore what they will do, so all teachers are scared to death. सच्ची में बोलो तुम AI यूज किया है कि नहीं किया, ठीक से बोलो. Scolding is going on. So whether it is in assessment, we have all used to create question papers, answer sheets. It's very, very useful. Delivery, analytics. I will show you one interaction. Can you press this one? No, not this one. Previous, no. There was a link there. Oh, I did not load the. Shall I load this? Yes, there is a small video. You should see this video. This is made by an AI. Just give me a minute. It's very interesting. Just play the video. Just play the video once. I'll conclude in 2 minutes. Warning आ गया, conclude. Just play the video, make it full screen and play the video. With sound. Not playing? Yes. Question paper, question pasted.
I'm not sure how to start. Can you help me with this question?
Hi, Nisha. I see you are trying to solve a problem about Newton's laws of motion. Drawing a free body diagram would be a great way to start.
Okay.
This is a live session I have recorded by a startup coming up in Bangalore.
Can you check if this is correct?
Looks good.
This is all live.
The other end is free.
This is not a recorded
The pulley moves down
trained
by
session. It's all live.
The rope must move down by 2L. L from each side of the pulley. So, anything attached to the free end of the rope will also move down by L, while the rope itself moves 2L to allow that. The same logic applies to acceleration. If the pulley accelerates downward at A, the movable end of the rope will accelerate at 2A. Did you understand that, or do you have any doubts about this?
Okay, got it. So the 2 kg block will accelerate by 2a. Now I'm going to solve for t and a from here.
Good going so far, Nisha.
You can stop it because it will solve the problem by this interaction method. So as I said, today we teachers are in bad state. We don't know who has written the assignment. So there are ways in which you can do teaching. I don't want to go into it. Of which, other than giving prompts, there is this whole concept of delivery enchantment. You can now tell somebody to make a joke using Einstein style to describe something else. And you try it, it will just be fun. But. Is this beyond AI? No. Rembrandt, Bach, Beethoven, all recreated. And as we know, that everything about us is known. Everything about us is known by AI. Look at this. This looks like an illusion, right? But AI will see everything straight because if you measure it, all of it is straight line. So AI does not see it the way we see it. This is number one. Therefore, AI will just measure the distance and everything is straight. Therefore, the other thing is also true. If we see something and we change only 20 pixels of a 1 million pixel image, we can make AI feel that the red light is actually a green light, which is called an adversarial attack. And because of its property, you can show that you can attack any image system. Till now, like viruses, there is no foolproof AI methodology. Everything is prone to adversarial attacks. So you can imagine the dangers. Hallucinations. It just tries to produce, many of the times when we don't know something, we guess. ऐसे ही तो होगा. AI does exactly that. So how to make AI interpretable, how to do that is very, very important, and that is what is being taught nowadays. So everything is changing. Even personhood is getting redefined. Law is getting redefined. Jobs, weapons. I said AI robots have gone on hartal. But whose problems are we solving? Whose problems are we solving? We are trying to make sure that the air conditioner wind is on your head so that your temperature of your head does not grow. We are getting money to make the life of people comfortable who are already very comfortable. So are we doing that? So how do we do that? So I think we should go towards a human-centric approach and more self-reliant AI. Otherwise, we will learn from others. We will learn history from others. We will learn history from LLMs. We will forget about our own history. We will only learn John, Ton, Adam, Thomas. We will forget. We will learn Ramayana taught by them. We will learn Mahabharata taught by them. So this is what we should be pondering about. Thank you very much. Sorry for taking too much time.
Ladies and gentlemen, please give a big round of applause for such a thought-provoking session.